Hello, my name is Nigel Day and I work for a company called INEA. I'm product manager for their Polyhedra database products, and we've just ported Polyhedra to run on the Raspberry Pi, so I thought I'd take this opportunity to show you Polyhedra running on that platform. The Raspberry Pi is an educational computer or hobbyist computer, single board, ARM-based, fair amount of RAM, a large number of interfaces, including some general purpose I/O interfaces. You can either build it or assemble it as a complete computer standalone, or you can use it in a headless situation using the Ethernet connection. And that's the way I've got it set up in this demo. If you want to find out more about the Raspberry Pi, then visit the website of the charity, which is www.raspberrypi.org. Polyhedra is a relational database system. It's been specifically designed for use in embedded systems, originally SCADA type applications, process control, but also telecoms and a wide variety of other uses. Because data security is quite important to them, to such markets, we've made sure it uses the client-server model. Because performance is important, then we make sure it's very fast and low footprint. In particular, the in-memory version of Polyhedra is particularly fast. On a platform such as the Raspberry Pi, we still get thousands of transactions a second. It runs on a wide variety of platforms, and clients on one platform can talk to servers on the other, even if they're completely different operating systems and machine architectures. I'm going to be running it today, obviously, on the Raspberry Pi, and I'm going to be driving the GPIO. So I'll be driving some LEDs just to show that it can be done like that. The setup I'm going to use for the demo is I'm going to connect in using PuTTY from a Windows box to connect into the SSH server running on the Raspberry Pi. I'm going to have a webcam pointing at the Raspberry Pi itself, so you can see the lights change in response to changes that I make to the database. Okay, so let's cut to the chase and get into the demo. Okay, so now this is the setup we saw before, and this is the PuTTY window, and the kit that you see shown in this bottom left-hand corner was supplied by a company called SK Pang here in the UK, and they also supply a little demo showing how to illustrate how to drive the LEDs of the GPIO. Now I could just try traffic light, but I can't do that because it's important to run as superuser if you're wanting to drive the GPIO. So now it's running a traffic light demo supplied by the manufacturer of this little kit, and you can see the lights changing. Okay, well that's not Polyhedra, so I'm going to cut out of that, and now I'm going to start up a Polyhedra database and run it in the background. Okay, the database is running, and I could run clients on here to show it's a relational database, but I'm just going to show the cross-platform nature by running the client application on the Windows machine. So here you've got a Windows command line interface allowing me to type raw SQL straight at the database. So what I'm going to do here is to do a query, and I can see that I've got 6 entries in here with various true-false values. Now these light values don't correspond to the lights that has been left in the traffic light demo I was running earlier. What I'm instead going to do is run again as superuser a little Polyhedra client application I've put together. Sorry, finger trouble. Okay, now when that is run, it launches an active query on the database, and the database tells it that 2 of the lights should be on and the other ones should be off, and that's what it's done. Because it's got an active query, it will be told whenever the database changes. So if I go through now and update the lights, then all the lights come on. And it's also, I can turn them all off again very easily. And if I wanted to, I could be selective about which lights I wanted to turn on or off. I could group a number of statements together into a single transaction. Okay, now also in this database, I've got a couple of other tables. First of all, there's the traffic light table, which groups together a number of lights. And so I've got one traffic light record which indicates the north-south traffic, and the lights that it controls are number 17, 21 and 22, and east is controlling the other three. And I've grouped these lights into a more complex thing called a junction. Now, Polyhedra allows you to attach trigger codes to the database. So if I go to one of these, if I go to the junction and change the state, the code attached to that table will propagate through to the lights the state it is in. So I'm going to update the junction. And as a result, corresponding to this state, both the lights ought to be off. I can say step through, and what is happening here is that the traffic lights, the junction propagates the state through to the traffic light record, and code on the traffic light record then propagates it through to the light. So if I go and change the lights, then every time I hit this command, you can see the lights are changing in sequence. Okay, now what I can do is, I'm lazy and I don't like just typing in commands like that, so I've got a little timer derived class which I can enable, and this will automatically alter the state of the junction for me. And all I need to do that is update timer set active equal to true. I've only got one record in this table, so no need to select which one. And now you can see the lights are changing. Now a timer has got a clock associated with an interval associated with it, so I can change the interval and the lights will go faster. And now we can see everything stepping through much faster, and faster again, and faster again, and faster again, until it's all blinking so fast you can't see what's happening. And even if I'm changing it hundreds of times a second, the database load is very low, and the load put on by that little client which is monitoring the database is even lower still. So what we've got here is a database which is running in user space, and clients can update it, either local or remote clients can update it. And I've also got a single client running in superuser space which is monitoring certain tables, and as the values change in those records, it is propagating through to these GPIO lines which cause the lights to change. It's not a particularly sophisticated little application, but it's nice that you can control it all via SQL. The controlling clients all being in user space, it doesn't matter too much if they crash, because them going wrong does not do anything dangerous in superuser space. Okay, so now back to the demo and back to the slide set, and we can see what I've done here is I've gone into the Raspberry Pi from a Windows machine and run a little demo supplied by the kit maker. Then I ran a database and had a simple client running in superuser space which propagated information from that database to the GPIO. The database server and its clients and all the trigger code attached to the database all run in user space, and you're not trusting that much that is running inside the superuser space. It's a good idea to minimize the amount of code that is running inside the superuser space in any system, because the privileges they have are godlike. So now a little bit more about Polyhedra itself, and Polyhedra Lite in particular. We've just released a free version of Polyhedra Lite. It does, and this is what I was running in the demo, it supports client-server operations, as you saw. It's got active queries and the trigger code. And it's on the Raspberry Pi, obviously, but also it's on Windows, Linux, Linux for the x86 platforms, and our own near Linux. If you want more information about Polyhedra, you can go to the polyhedra.com website. And we've also set up a new developer website with the manuals, lots of reference material, white papers, and so forth. And I intend putting the code of the demo I've been running up on this developer website very soon. I hope you take the time to download a copy of Polyhedra Lite for yourself, and if you've got any problems, get in touch with us.